Can you stretch a spring without even touching it? Well, technically, no. But understanding how force really works on a spring might just stretch your mind. Let's break physics with Hooke. The force acting on a spring is governed by one of the most elegant laws in physics, Hooke's law. It states that the force or load applied to a spring is directly proportional to its extension, as long as we don't cross the elastic limit. That means if you double the load, you double the stretch. Triple the load? Yep, triple the extension until the spring snaps out of line, literally. By the way, the original experiments for Hooke's law were done in the 1600s using catgut strings. Turns out science was already pulling some strings back then. Hooke's law is mathematically expressed as load, denoted by F over extension, denoted by X, is equal to constant, denoted by K, or simply F over X is equal to K, where F is the force applied to the spring, measured in newtons, K is the measure of the spring's stiffness, measured in newtons per meter, and X is the change in length of the spring from its original unstressed length, measured in meters. The spring constant, K, is a specific characteristic of the spring. A larger constant indicates a stiffer spring, which requires a larger load to produce a given extension. On the other hand, a smaller constant means the spring is more easily extended. Positive extension, X, refers to stretching, while negative extension indicates compression. Hooke's law isn't just equations on paper. When you graph load F on the y-axis and extension X on the x-axis, the result is a beautiful straight line. The steeper the line, the stiffer the spring. The slope of that line? That's your spring constant, K. Here's a quick challenge. What do you think happens on the graph when the spring passes its elastic limit? Share your thought in the comments below. Let's plug in a real-world example. Say a spring has a spring constant K is equal to 100 Newton per meter, and you hang a 50N weight on it. Calculate the extension. F over X is equal to K. As we are looking for X, then the formula becomes X is equal to F over K. F is 50 and K is 100. This gives 0.5 meters as the extension of the spring. But here's the catch. Hooke's law has a boundary. Beyond the elastic limit, the spring may deform permanently. That means, once you've overdone it, there's no going back, like stretching your luck just a little too far. To recap, the force acting on a spring is elaborated by Hooke's law. Hooke's law states that the force, or load applied to the spring, is directly proportional to its extension, provided it does not pass the elastic limit. The law is mathematically expressed as load over extension is equal to constant. From slinkies to seismic shock absorbers, Hooke's law is everywhere. Yet it starts with the simple idea that force and extension are best friends, until the elastic limit breaks them up. Now that you've mastered the force on a spring, in the next video, we'll dive into forces that affect circular motion.